P, coordinates given by x, y, z, be a point in space such that r bar is equal to OP bar. It has direction cosines L, M, N. Then L into magnitude of r bar, M into magnitude of r bar, N into magnitude of r bar are projections of r bar on OX, OY and OZ respectively. So this requires a little bit of imagination. Okay. Suppose these three are the mutually perpendicular axes. Suppose we have a point here. Given by x, y and z. This is the x-axis, this is the y-axis, this is the z-axis. Okay. Now this point P is floating freely in space somewhere. It is not on any one of the standard planes x, y, y, z or zx planes, right? So it is somewhere in between them. So if you want to find out the shadow, the projection of the point P on the x-axis, what would you do? You would draw the shortest distance between the point P and the x-axis. Let's say this is that distance. Let's call it PM. And O is the origin. If we do this, then the length OM is equal to the x coordinate of this point, right? And let's say this is the angle alpha that the vector OP makes with the positive x-axis. Then L equals cos alpha. But what is cos alpha? Cos alpha is the adjacent side of the triangle OMP. So that's x divided by the length of the vector OP, which is OP bar or R, the magnitude of R bar. And thus we get x is equal to L into magnitude of R bar. Likewise, you can get y coordinate as M into magnitude of R bar and z coordinate as N into magnitude of R bar. So these, the projections, the shadows of the line OP which falls on the respective x, y and z axis are called the projections of the point, what we call adjacent sides in trigonometry. Therefore, x is equal to L into magnitude of R bar, y equals to cos beta M into magnitude of R bar and z is equal to cos gamma, that is N into magnitude of R bar. So therefore, if you want to combine all of these, we get the vector OP bar, that is R bar. So R bar is given by magnitude of R bar into L I cap plus M j cap plus N k cap, right? So therefore, we get R cap is equal to L I cap plus M j cap plus N k cap, right? Because then we can write the vector R bar is equal to magnitude of R bar times R cap, which is a unit vector. Moreover, it is possible to prove very easily that the sum of the squares of the direction cosines of any one particular line add up to 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1.